Dr. G. Ravindranath Reddy, working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So now we are in the concept in the course of numerical methods and integral transforms. In that course, we are discussing how to find out the curl of a vector point function. In this video, we will discuss how to find out the curl of a vector point function, and if that curl of that vector point function is equal to 0 bar, then what will be that vector point function? So, and we will take some problems on this concept here. So first we will take curl of a vector point function. So we know that, so f bar, suppose if we consider f bar is equal to f1 I bar plus f2 j bar plus f3 k bar, and now for this vector we are going to apply how to find out the curl. So that curl of f bar is represented with del cross f bar. So already we have seen what is a del operator. You take the del operator here and apply the cross product for these vectors here, this f bar. So in simple way we can say that curl f bar value can be, we can get that curl f bar value as determinant of, take the vectors I bar, j bar, k bar and take its I bar coefficient in the del operator, that is dou by dou x. So this is del is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. So here I bar coefficient in the del operator is dou by dou x, j bar coefficient in the del operator is dou by dou y, and k bar coefficient in the del operator is dou by dou z. So replace that values, coefficients in the second row, and now go to the f bar. So f bar, in the f bar the I bar coefficient is given by f1, j bar coefficient is given by f2 and k bar coefficient is given by f3. Now we know how to find out the determinant of this. You find out the determinant, whatever the determinant value we get, that value we can consider as a curl f bar value, which is represented with del cross f bar. So del cross f bar, whenever we apply the curl for the vector point function, then the resultant is also a vector point function. So whenever we apply curl concept for the vector, it also finally you will get a resultant is an a vector itself. So now we will take the irrotational vector. What is meant by irrotational vector here? So I have taken a vector point function. Now if we want to say that this vector point function f bar is an irrotational, whatever we get the curl f bar value, that curl f bar value must be equal to the 0 vector, not 0 vector, that is 0 I bar plus 0 j bar plus 0 k bar. So if this curl f bar value is equal to this 0 vector, then that f bar we can consider as a irrotational vector. So whenever the given vector is irrotational vector, then there exists a scalar point function phi of x comma y comma z. So how can this scalar point function exist? Such that f bar is equal to gradient phi. So whatever the scalar point function we got, if we apply the gradient for this, then this f bar, that value is equal to the given vector. So then whatever the scalar point function we got, that scalar point function we can call it as a scalar potential. So this scalar potential you will get only whenever the given vector is an irrotational vector here. That point we have to remember. So whenever the given vector is an irrotational vector, there exists a scalar point function phi of x comma y comma z. That scalar point function satisfies this condition, f bar is equal to grade pi. So that whatever the scalar point function we got, that scalar point function we can call it as a scalar potential for the given vector. So this is about irrotational vector. Now we will take some problems on this. So this is the vector he has given. For this vector we have to find out the curl f bar value at this particular point. So first take the vector, whatever the vector he has given in the problem, write down that vector. So now we have seen curl f bar is equal to del cross f bar. So that is given by I bar, j bar, k bar, dou by dou x. Find out the determinant here. So this vector we have to compare with f1 I bar plus f2 j bar plus f3 k bar. Compare the given vector with this. Get the value of f1, f2, f3 and take this f1 value, f2 and f3. So now we know how to find out the determinant of this 3 by 3 matrix. Find out the determinant of 3 by 3 matrix here. So finally you will get this vector here. So this is the vector we get in terms of x, y, z. Now suppose if the point is not given, then we can stop our problem at this point. Whenever the point is given, we have to substitute that point in the curl F bar. In place of x, y, z, we have to substitute that values here. So curl F bar at this particular point is given by, so put this is x value, x is equal to 1, y is equal to -1 and z is equal to 1. Substitute these values in this, we can get our required curl F bar value at that particular point. Now once if you observe this one, at the beginning he has given F bar value. For this we have applied the curl concept. At final also we got the vector point function. So whenever we apply the curl for the given vector point function, the final value is also a vector. So now you will take another one. So this is an irrotational vector. So we have to prove that this is an irrotational vector. So when already we have seen, whenever we get an irrotational vector, there exists some scalar potential. We have to find out that scalar potential here. So first one is, you consider this as a vector point function. You prove that F bar is an irrotational. That means it is enough to prove that. In order to prove that irrotational, it is enough to prove that curl F bar is equal to 0 bar. If curl F bar is equal to 0 bar, then we can say that the vector is irrotational. Whenever the vector is irrotational, then there exists a scalar point function. That is, we have to find out the value of pi of x comma y comma z. That is the meaning of this problem. So first we will concentrate on this. So we know how to find out the curl F bar value. You substitute that partial derivatives, so this f1, f2, f3. Find out the determinant of 3 by 3 matrix here. Then find out the partial derivatives here. So here after finding this, all the y values, y plus minus x plus x, minus y plus y, minus z plus z, this gets cancelled. 0 into anything equal to here. So this becomes 0 I bar minus r plus 0 j bar plus 0 k bar. So this is represented with the 0 vector here. So finally we got curl F bar is equal to 0 bar. So whenever this curl F bar is equal to 0 bar, we can say that F bar is an irrotational vector. So whenever the F bar is an irrotational vector, then you will get some scalar potential, scalar point function which satisfies this condition. Now our task is, we have to find out that pi value here. So now we'll see how to find out this. Use the condition here. F bar is equal to del pi. F bar, whatever the value of F bar he has given, you take that F bar, and del pi is given by this I bar dou pi by dou x plus j bar dou pi by dou y plus k bar dou pi by dou z. Now equate this. So both sides, in between these two you are having equality symbol, equal symbol. Now equate the I bar coefficient, j bar coefficient and k bar coefficients on both sides. So by comparing the components, we get dou pi by dou x is equal to I bar coefficient here, and dou pi by dou y is equal to j bar. Now like this you compare and you concentrate. From this dou pi by dou x we have to get the value of pi. So how can you find out the value of pi here? So we have to cancel this partial derivative here. So how can you cancel this partial derivative? We have to apply integrals partially. So whenever we want to cancel the derivatives, you apply its reciprocal, that is integration. That integration and derivative gets cancelled here. Then you can get our required function. And since here we are applying the partial derivatives with respect to x, now apply the integration partially only with respect to x, and the remaining two variables we have to consider as constant. Okay, so applying the partial integration with respect to x, we will get for integral of this function x square minus yz and dx. Here we have to consider y and z are constant because we are applying the partial integration. So derivative of x square is x cubed by 3. So since y and z are constant, so we can take that constant outside. You will get yz into the remaining one is, after taking yz outside, the remaining one is 1 into dx. Integral of 1 into dx, that is x into yz, xyz. And we have to add some integral constant here. So that constant, since you are applying the partial derivative, that constant may be a constant, or you may have function in terms of y and z. So suppose if you have the function yz, if we apply the partial derivative with respect to x here, this also becomes a 0. We don't have any problem. And suppose if you consider here in the last term, if we consider some constant, derivative of constant is also equal to 0. So here in the last one, you may have some integral constant, or you may have a function in terms of y and z also. So these two cases we are having. So you consider that as C or f1 of yz function. And similarly, take dou pi by dou y and apply the partial integration with respect to y in order to get pi here. So you will get here. So since you are applying the integration with respect to y, so the constant, you may get constant value, or you may get a function in terms of xz. So whenever we apply the partial derivative with respect to y, we have to get this value here. So here in the last term, if you have constant, the partial derivative of constant is 0, or even the function if you have in terms of xz, whenever we apply with respect to y, this also becomes 0. So these are the two cases we are having. So we can take any one here. So dou pi by dou z, find out similarly here. So now in equation 1, equation 2, equation 3, you are having pi values here. Now from these pi values, 3 pi values, we have to get 1 pi value here. Now we'll see how to get that pi value here. So from 1, 2 and 3. So how can you get this here? First you concentrate on the 3 equations, and now from these 3 equations we are going to get our required pi value here. So from these 3 equations, first write down the non-repeated terms here. X cube by 3, we got only one time in these 3 equations, so take x cube by 3. Next, similarly y cube by 3 plus z cube by 3. These 3 terms are not repeated in these 3 equations, we got only one time. So first write down that. And whereas here we are having minus xyz, here we are having minus xyz, here we are having minus xyz. So minus xyz is repeated twice. So now, even though if it is repeated twice or thrice, you consider as a single term here. So minus xyz. And this one, c constant, so we can take one constant here. So this is our integral constant. This is our required pi value here. So this is our required scalar potential for the given problem. So constant, which is our scalar potential. And similarly, here also we can, this is a irrotational vector he has given. So in this irrotational vector, we have some unknown parameters a, b and c here. Now our task is, if the given vector is an irrotational vector, then find out the constant values here. That is our problem. So how can you say that the given vector is irrotational? Curl f bar is equal to 0 bar. So first find out the value of curl f bar. You equate that value to the 0 vector. Now equate the I bar coefficient, J bar coefficient and K bar coefficient from both sides. Then find out that A value, B value, C value here. Now this is our vector f bar. Find out the curl f bar value. So replace that f1, f2, f3. This is our curl f bar value here. So we are given that this is a irrotational vector. So whenever the vector is rotational, then its curl f bar value is equal to 0 bar. What is our 0 bar? That is a 0 vector which is given by 0 I bar, 0 J bar plus 0 K bar. Now here I bar coefficient, J bar coefficient, K bar coefficient. These two, in between these two vectors we are having the equality. So whenever that I bar coefficient, J bar coefficient, K bar coefficients are equal, then we can say that two vectors are equal. So use this, compare this. So now I bar coefficient is c minus 3 and this is equal to 0, and J bar coefficient is minus of 2 minus A, which is also equal to 0. Here J bar coefficient is 0 and the K bar coefficient is B minus 3, and equate that to K bar coefficient on RHS, that is 0. Now this, from this you will get C is equal to 3. So you will get A is equal to 2 and B is equal to 3. So this is the way how we can get this constant values, unknown parameters values when the given vector point function is irrotational. So in this we have discussed how to find out curl of a given vector point function, and some example problems we have seen under this concept. So with this we have completed our course numerical methods and integral transforms. Thank you.